Now with all the hate that Nissan's given its continuously variable transmission, a lot of eyes have been turned to Subaru for the reliability of their transmission since it's a completely different design. Here we have a TR690, which is out of a 2012 Subaru Outback with a 2.5 engine. Now this only has 91,000 kilometers on it, so today we're going to tear it down to see what's inside, how it works, and just what caused these transmissions to fail. Now if you guys like the work that I do, make sure you support me on Patreon by checking out Speedcar99. Taking a quick look around the transmission at the front here is where the starter would bolt up to. Got some electrical connections and the transmission tube vent. This big black thing here is a jacket to keep the transmission nice and warm in the winter, especially on a cold day like today. Here we've got our transmission cooler lines that go out to the radiator, and at the back here we have our all-wheel drive system, so that'll be pretty cool to take apart. Now this is a longitudinally mounted transmission, so our rear drive shaft is going to mount at the back here, and inside we have a front prop shaft and a front differential where the axles are going to plug into here. So the front axle line is here, and you've got the entire weight of the engine sitting in front of the front axle there. That's not very good for handling. Most longitudinally mounted cars will have a prop shaft going underneath the engine, and that's where the front differential would be. Now the torque converter was one of the biggest issues with this transmission, so we're probably going to have to cut this one apart, and we'll take a look at it later. I'm going to start this teardown by removing this jacket. Next I'll get this tail housing off here. Over here we have the parking pawl that's going to lock that shaft over there, so it locks the wheels and prevent it from turning when you're in park. And then at the back there we have the whole clutch mechanism. And I could take out this tail shaft here, which ultimately connects to the drive shaft going to the back. Now the all-wheel drive system in this vehicle is a little bit more rudimentary. If you want to see something more interesting, check out the 2005 Outback video I made on symmetrical all-wheel drive. That one is a lot more complicated. This one here has the output coming from the transmission going into here. The front wheels are splined to it, so they're always turning directly with a 1-to-1 ratio, and that's going to turn this gear here, which in turn is going to go through the prop shaft and turn the front wheels. The rear wheels, however, are decoupled from that with this clutch. So let's say the valve body commands this clutch, it's going to pump fluid through this hole over here down the shaft to either partially or fully lock up this clutch here to give you your torque split. So for example, if you want to fully lock it up, you're going to have a 50-50 torque split, and this whole thing is going to rotate as one assembly with both front and rear wheels moving at the same time. Of course, if you partially lock this up, you can vary that torque split depending on conditions for a more front bias. Or if your front wheels are completely on ice, all of that torque is going to be sent to the rear wheels to give you traction. Moreover, what having a clutch allows you to do is a wheel speed difference between the two. So for example, you're turning on a corner, the front wheels have a different wheel speed than the rear wheels. This clutch is going to have compliance in it to allow those wheel speed differences. So let's pull this apart here. You can see this is the tail shaft piece. There's a thrust bearing in there, and the rest of it. Pop this clutch out. Here is the all-wheel drive clutch. It's in pretty decent shape. Essentially you have these steel bands on the outside that are toothed to the output from the transmission, and the friction discs, which are these brown ones that are toothed on the inside, which are going to engage with the tail piece that goes to the rear wheels. So by locking the front wheels and therefore the output of the transmission to the rear wheels, you can get that torque transfer. Alright, so you missed that, but I took out the circlip, and here is the piston itself with a seal that goes around. The back of this is going to fill up with fluid inside of the cylinder over here. There's also this piston return spring that's always putting pressure on those clutches. Now if you look closely in here, you can see that there's these little holes, and that's the hole that's going to take fluid from this side over here to fill up that piston, press against that clutch to lock it up. To be honest, I was expecting a full-on Planetary differential inside of here, but this one's not that complicated. Next up, I'm going to get off the second half of this tail housing over here. I'm going to pull out the front prop shaft gear here. Only 91,000 kilometers, and we already have some metallic paste in here. So it looks like all the CVT oil that's coming out is actually colored like engine oil and not like transmission red. Now the back of the second casing here, we have a clutch pack, and that's going to spline to this Planetary, which is basically the final output of the transmission. Here we have a filter. Not very good that it's internal to the transmission, but at least there is one. Now the reason why you need this Planetary gear set is to enable reverse, because the CVT belts are only going to turn with the engine direction. In order to get reverse, you got to have this Planetary gear set and a clutch to lock it up. So I'm just going to pop this out here. So here's the forward and reverse clutch pack. I'm going to remove this Planet carrier. Here we go. And that is splined to the clutch that's locked into the transmission casing. So how this works is we have the input, which is this one here coming from the variators, and that's going to power this ring gear over here. Then we have the sun gear over here, which has these splines inside of here, and that's going to power the transfer case, which is the output of the transmission. Now these two are clutched together with the forward clutch, which is inside of here. So if you apply hydraulic pressure to these, it's going to lock the input to the output, and the whole thing is going to rotate as one assembly, and that's how you get your forward gear. Now if you release pressure from the forward clutch and apply it to the reverse brake, this planetary gear set is now going to remain stationary, and look what happens. My input is now reversed to this output, which is the sun gear here, and that's how you get reverse gear. Pop all these clutches. Yeah, these are actually in pretty decent condition. They're actually brown and not black, not really worn down, no friction material or heat spots or anything like that. Alright, let's see if I can pull off the forward clutch here. This is also in pretty good shape. Again, not that much mileage. And this here is the piston that's going to apply that clutch. I'm going to take a minute and remove all of these hoses and wiring. So if you notice, this vent here actually kind of points downward, and that's to prevent water from kind of ingressing in. If you do happen to go underwater, this could potentially bring water into the transmission. So those of you guys who are restoring flood cars, please change the transmission fluid before you start it. This one's for the transmission and this one's for the differential. Note, they don't have any more dipsticks. The older style did have a dipstick. On the side here we have a pressure switch. I hate how they couldn't just give you a connector here. You got to go inside the valve body and disconnect the solenoids. I'm going to remove this park neutral switch. Alright, with the transmission on the side, good time to knock the pan off. I discovered that a floor scraper might actually be an easier, less violent way of getting a pan off. Okay, we got some more fluid in there. Taking a look at this transmission, the oil itself actually looks to be in decent shape. The magnet, however, has caught a little bit of particles from the clutches and the belt wearing out, and that is what its job is. Now this thing here is a transmission filter, so we had the inline filter at the back, and we have this one here, which is good. I like to see that. At least there's something that's serviceable. If you look at the shape of the pan, this is where the drain plug is. It's a bit higher, so all the fluid and stuff that's sitting at the bottom here, you're not actually getting it out with the drain and fill. You really have to drop the pan, change the filter, and clean out the pan itself if you want to get all the gunk out. At least it's metal and not plastic like some people. Magnet looks like it's removed. Oh my goodness, look at the sludge on that magnet. Whenever you're doing a transmission job that gets really oily, it's always a good idea to have your sister-in-law's scarf or any other absorbent material ready, because your hands are going to get so slippery and oily, and if you're not married, you're not going to be used to having slippery hands. So here we have the valve body, which is the brains of the transmission. This is the input for the fluid coming from the filter. It looks like all of the black bolts are the one that hold it to the casing. It's days like today where I regret not draining the transmission before bringing it into the garage. Alright, I'm going to remove this valve body. Now this valve body is the brains of the transmission, redirecting fluid flow inside of the casing over here, so you can either lock up clutches, control the all-wheel drive system, or control the variators. Now one of the biggest problems with these CVTs is the solenoids, specifically this one here that controls the torque converter lockup. Now you'd normally lock up your torque converter if you're on the highway and you don't really need any slip between the torque converter and the transmission. However, if this solenoid goes bad, it can cause that torque converter to lock up, and when you come to a stop, it stalls out your engine. The torque converter itself was also revised so that it can fix this issue, but if you've got one of these, you will actually need to replace the entire valve body, because Subaru doesn't sell these solenoids separately. I mean, hey, if anybody wants these solenoids or valve bodies after I'm done with it, it's going in the scrap. Now's the part where I start taking out every 10mm bolt that I see. That's the bugger that causes a lot of these transmissions to go down. Alright, so here's the mess of a wiring harness and solenoids off of the valve body. Alright, flipping it over, looks like I got another 2 dozen more fasteners to take out. So much mess. Oh goodness. Pop this open. A steel plate. Essentially what those solenoids and valves do is they direct fluid flow to form hydraulic circuits, and those circuits are what going to fill up those clutch packs that we saw and therefore control the transmission. Now if one of those solenoids fail, either they're stuck on, then they're always sending fluid pressure to, say, the torque converter or the all-wheel drive system, or if they're stuck off, then they can't even engage it and you've always got slip in the torque converter. Next we'll move to the front of the transmission. This is where the torque converter lives, but you'll see inside of here we do have an extra case, and that's for the oil pump chain and the oil pump itself, which resides in this area. We've got 2 different kinds of fluids in here. In the front half of this casing is the differential oil or gear oil, and in the back is the CVT oil, and you can't mix them. So make sure you don't mix up this drain plug with the one on the transmission when you're doing your fluid changes. Let's see if I can get in here. I think I'm going to run out of pry bars. I'm going to try to remove this oil pump housing first. So inside this housing there's a chain that feeds the oil pump, which is the oil pump shaft here. Alright, so with the input speed sensor moved out of the way, I can take out this gear set here. This is the input shaft, and it looks like this is an input sprag bearing or something. Alright, don't be like me and forget this piece in here. I think that was causing this thing to hang up for hours. Yay! Finally got that. And here we have the guts of the Subaru continuously variable transmission. Very interesting because it's actually a longitudinally mounted transmission. We've got the input that comes in here to the primary variator. It's got this giant piston in here that's going to adjust the drive ratio. Right now it's at its smallest position. And then we've got the secondary variator over here. It's currently sitting at its largest ratio over here. It's a little difficult for me to turn because it's really slippery and oily, and the hole isn't lined up with the bottom here. So it looks like we've got these plastic guards here. I'm going to remove that. Oh, it's heavy. Now, in order for me to get this plastic off, I actually got to get the belt off. Now, there's a giant spring that's inside of this variator here that's always pushing this way, squeezing the belt, so it's at its highest most position on the output side, and therefore on its lowest most position on the input side with no oil pressure. Of course, when you add oil pressure or reduce oil pressure on this side here, that's how you're able to vary the drive ratio as the belt rides up against these cones. Now, having it default in this first gear is beneficial because it'll allow you to just move the vehicle around or just get it off the road, kind of a fail-safe. So I've got my impact on a 3-jaw puller here, so I'm going to squeeze that return spring open so that I can get enough slack in that belt. Maybe. There we go. So as you can see, the fluid pressure that has to build inside of here or relax has to work against this giant spring pressure. Now this is more of a chain rather than a belt. It feels like a transfer case chain. It's actually very heavy and very sturdy. It feels like it could take tension and compression, and it's made up of very small links that are riveted on either side. Now here's a belt out of that Corolla CVT that I took apart. Link above if you want to check that out. It's actually very similar to Nissan designs as well, where it's got many tiny little pieces that run across here and 2 steel belts that hold everything together. Now in reality, if I didn't have these zip ties on here, these steel belts would fall out and this entire belt would come apart in hundreds of pieces, and I'd have such a mess to clean up across my garage. I mean, it's pretty straightforward, guys. Corolla, Outback. Yeah, I know they're 2 different size vehicles, but this feels like it could fit in a truck. Now, of course, the rivets on the side here have to have a little chamfer to them to match the cone angle over here for smooth operation. Now, this entire thing is encased in fluid to help prevent wear, but obviously over time there can be wear on this surface here. So here's the input variator. There's no return spring inside of here, so I can actually move it in and out. This is all controlled through hydraulic pressure, so when you add pressure inside of here, that's going to push this together, and that's going to allow the belt to ride to the outside diameter, and when the valve body decides to bleed off the pressure, this is allowed to move back in. Now what makes this continuously variable is the fact that you can move it infinitely amount. There's no set fixed gear ratios, unless if you do that in the transmission programming. Now on the secondary variator, we saw there's a giant spring inside of here, and as I compress this here, we'd be moving this outward this way. This also uses fluid pressure that's fed inside of here to fuel up this piston. Now of course all pistons can wear out or leak. This one's difficult to get off because I actually have to put it in a press, hold it down, then take the nut off, and then slowly release it. If I just cut the nut off, it might just fly out and kill me like it did in the Nissan video. Check that out, that was very interesting. I can, however, try to take the primary variator apart, so make sure you buckle up. Alright, I got the jaw puller on there. I'm going to pull off this outer cylinder. Alright, here we've got this outer cylinder. Unfortunately, I'm not able to get the piston to pop out, so what I really wanted to have a peek at is the seal. So essentially we got fluid coming in from the back here, filling up this cavity, and that's what's popping this variator out against the belt. Now having the seal is important because on Nissans, they put a rubber seal and that tends to disintegrate really fast. This one here, they actually use a metal kind of seal here, something you'd see like on a real engine piston ring. So I think that'll be more robust. Alright, back onto the transmission casing itself. I'm going to remove this. Take off the casing here. You can see this is where the torque converter is going to plug into on these 2 ears. And that chain is going to feed this little cog over here, which is where the oil pump plugs into. Oh yeah, this is the stator that also plugs into the torque converter for torque multiplication. Now the oil pump's located here, but we've got to take off this part of the casing here, which is held on by eTorx 20. These fasteners are way too shallow for an eTorx 20, so for the last half an hour, I've been busting it with a 14mm 12-point socket, just trying to hammer that on there. No! Now that all these bolts are finally broken free, my 14 socket's seen more banging than a 20-year-old. I can now use the proper socket, which is an E20, to zip these bolts off. Alrighty. Looks like we have the... Holy, it stinks in here. Inside here we got the oil pump and the pinion that drives the front differential. This is the stinker because gear oil always stinks. Here is the oil pump. And here you can see the inlet and outlet on the casing here for the oil to go in and out. Let's pull this apart real quick. Alright, looks like we got a gear style oil pump. So you can see as this rotates, oil is going to come in. It's going to flow around this way and it's going to get squeezed between these gears to be forced out that way. And that's how you get oil flow. This is the outlet. Interesting, there's a needle bearing inside here. I'm going to remove these 14s for the pinion. And sometimes these pinion bearings can go bad and make a whine. Remember, this is a front wheel drive car primarily because the rear wheels can be disengaged. So this is responsible for driving the car. Now this is the interface with the seal over here between the transmission fluid side on the back and the gear oil that sits inside of this differential. So here's the reason why they call it symmetrical all-wheel drive. That pinion is going to plug into this open differential over here, and the center line of the vehicle is over here. So you've got axles that are equal length coming in here for an equal torque distribution. Obviously the same thing is repeated on the rear differential where you've got equal length axles, so there's no bias for torque steer. Everything is symmetrical. Very simple open differential, just interesting that it's used to put it in front of the transmission as opposed to in front of the engine like most other normal people. Now if you want to learn more about how open differentials work, check out my link above because I'm not taking this out. And it doesn't matter if I take this differential out because I'm still going to be selling at high recovery aluminum prices as opposed to being pure aluminum. It's because there's these little iron bushings inside of here that prevents this from going as pure cast. And hey, why not have an extra couple of pounds of impurities in there to help your cost? It's a pretty nice pinion. You could probably use this to whack my brother next time he misbehaves, or I could So for this segment, I've moved outside. You can see the snow just so I can cut this torque converter open. It causes too much smoke inside of the garage. Alright, 2 blades and 15 minutes later I got it cut open. I've got a better video how torque converters works, you might want to check that out, but quick recap. Essentially you've got the outside here which is bolted to the flex plate and that's always rotating with the engine. Now inside of here we have the stator. Now the stator always stays stationary as it's splined to the transmission casing. Now inside of here free floating we have this piece here which is splined to the input shaft of the transmission. Now in order to transmit power as this is rotating, centripetal force is going to take that fluid and expel it out this way and then into these fins over here. And that expulsion of fluid is then going to cause this piece to rotate as the fluid moves through the fin. Now by having that stator in between here, it's going to cause the fluid to make a 90-degree turn from this way of the fin direction to this way, and that's actually going to help you multiply torque when you want to take off from a stop. So in essence you have a fluid coupling. Let's say the engine wants to keep turning but the transmission and wheels are stopped at a stoplight. Finally we have clutch lockup, and that happens at highway speeds where you don't need this slip in between here because that could lose your efficiency. Essentially the transmission is going to send fluid down inside of here and there's a clutch that's going to lock the input, which is the outside part here, to the output which goes into the transmission here together, so they rotate as a 1-to-1 ratio without any power loss. Pull this piece here. Now at the back here we have a friction-like material and that's going to press up against the outside casing here to lock that input to the output. Here we have a damper similar to a damper in the clutch system. Now when you pump hydraulic pressure, this plate is going to press up and essentially lock the engine side to the input transmission side, so you've got a 1-to-1 ratio. Now here's where we come to one of the issues with these Subaru CVTs, and that's this lockup clutch. As you can see, there's so much clutch material inside of here and it wears out pretty fast. Sometimes it can even clog this bushing that you see inside of here. That's where the input shaft plugs into and you send fluid down inside of here. Now sometimes the valve body might command this to depressurize. Let's say if you're coming down to a stop and you want to unlock this clutch here to allow for a little bit of slip as you're downshifting. Well, the design of this bushing might not allow that to unlock properly, especially over time as these things start to wear out, and then the clutch remains engaged. Now as the clutch remains engaged, you no longer have that slip between the input and the output, and then the wheels stop, and then that causes the engine to stall out. Of course, this is going to be accompanied by a couple of engine codes and flashing lights on your dashboard, so you will have plenty of warning of what's going on and where to fix it. Now Subaru's done a technical service bulletin to revise the design of this bushing area to help it bleed out faster. However, in order to replace this torque converter, you have to separate the engine and transmission. That means pulling things like axles and drive shafts out to get the transmission out. Yeah, so it's a lot of labor to do this kind of job. However, if you've got fluid clutch particles like this that we see inside of here, and like that pasty stuff we saw in the valve body, well, that's going to be floating around inside of the transmission, and that could clog up little arteries in the valve body or in the pipes that feed the clutches. So the more you start to ignore this problem, the more this clutch is going to wear out and throw clutch material all through the transmission, and then at that point you pretty much need a new one. I haven't filmed outside in a couple of months, and boy are my hands freezing. Thank goodness for the garage this year. I'm pretty sure you guys prefer the lighting outside of here, but too bad. I'm getting old and we had a really cold winter. And that's a look inside of the Subaru CVT and how it works. Now I do think this design is fairly robust, especially using a chain instead of a belt, but I do think it's a lot more overcomplex just to keep Subaru's design philosophy of being a symmetrical all-wheel drive system, packaging a transfer case and a differential and all the other guts inside of here make this a very heavy transmission. I mean, continuously variable transmissions are meant to improve economy, and Subarus are definitely not economical. I mean, there's a lot of other CVTs that power mostly the front wheels and sometimes the rear wheels that are more compact. Now, if you are looking for one of these, make sure you check records to see if the torque converter was done, that torque converter solenoid is working, as well as keep up on your fluid changes. Make sure you subscribe if you want to see more videos just like this one.